Okay, so we're going to start reviewing some of the different topics that we covered as we practice free responses and multiple choices. And so one of these things was the impulse and momentum. And so the first thing I'm going to talk about is when we want to use impulse and momentum. And so momentum and impulse we like to use whenever we see information about collisions. Okay. Whenever we see something relating force and time, okay, and sometimes when we have relationship between force and velocity. Now, sometimes for this we use momentum, sometimes for this we use energy, and that kind of depends. Okay, but these are the two big ones right here. Okay, so if you see two things collide, that should be a clue to you to use momentum. And if you see something talking about a force acting over a time, that would be another clue. Okay, just a reminder, this was chapter 9 from our textbook, and all the videos that I recorded that relate to momentum are still up on our course page. Okay, so if you look down here, this is our course page. If you look here, chapter 8, chapter 9, this is energy, momentum right there. So if you want to go back over momentum, watch some of those videos. They're right there for you to watch. So anyway, the next thing I'm going to go over with you though is the formula sheet, and just to remind some the momentum formulas are, remember where we can find them on the formula sheet and so on. Okay, so symbols that are relevant for momentum: impulse, which is J, P, which is momentum, okay, and those are the only ones for now. But over here we have some equations. This is a relevant momentum equation. What this is saying is that force is the rate of change of momentum. So force is equal to the slope of momentum. So if you have a momentum time graph, the force would be the slope. Also right here, this is pretty important, saying that impulse is the integral with respect to time of force and gives us the change in momentum. So if we have a graph that is force and time, finding the area is going to give us change in momentum. So if we knew what our momentum before was, if we add to it our change in momentum, that would give us our momentum after. Okay, and then the other one here that's going to be relevant is just that P is equal to mv. If you forgot how to calculate momentum, it's right here. And so these are really the only three pieces you need to know. And they're all located right here together on your formula sheet. So a couple other things to remember: that momentum is constant, unless there's a force acting on it. So the momentum of a system would stay the same. That's why it's really useful for collisions. If you have two objects interacting with each other, their total momentum has to stay the same. The only reason it would change is if some external force acted on it for some time. Okay, and so again we call that change impulse. And impulse, in addition to being calculated this way, can be calculated multiplying just force times time. Momentum is a vector, which means that the direction matters. And we can have momentum conservation questions in the I and J direction, or even the K direction, depending. And the whole process works exactly the same way, just now using two different dimensions. And this is really everything. If as I continue recording these review videos, if there's more information you want to see, please let me know, but otherwise they're going to be pretty short. If you want to go back and review any of these things, you can go back to that chapter 9 section, go back over some of those videos, or there should be a momentum section in your review book as well.